Hey, today we're going to be talking about reverse engineering. What you guys are going to learn, you're going to learn what is reverse engineering, why is reverse engineering used, and what are the stages of reverse engineering. The first step of reverse engineering is visual analysis. And we've done a couple assignments over the last couple of days where you guys were identifying the elements and principles of design, and this is the visual analysis. In this step, we would not be tearing anything apart. I repeat, would not be tearing anything apart. We're just simply looking at it and looking at it to determine what are the design principles, what are the elements uh, elements of design that are used in this as they created it. What is reverse engineering? Reverse engineering is the process of taking something apart and analyzing its workings in detail, usually with the intention of understanding its structure, function, and operation. Well, one of the first things that you guys probably ever came across that was reverse engineering is in the first Transformers movie. They talk about how they have Megatron strapped up and they've got him frozen on cryogenics. And they've used reverse engineered a lot of the things that we talk about that we have nowadays, like fiber optics, telecommunications. A lot of those things they say in the movie, not necessarily true, that those things were developed for humans to use by reverse engineering from Megatron. Reverse engineering and innovation. These two go hand in hand, all right? They're sisters, they're brothers, they're cousins, whatever you want to say. But we've discussed innovation where we take a product and make it better. All right, well, here's an example of one of the very first cell phones. I had one like one on the left, and now I have one that's similar to the one on the right. But there's several steps, several innovation steps that have gone along the way to get us from here to here. And a lot of times the way we innovate is by reverse engineering. At first, someone had made this phone over here. Some company bought it, tore it apart, and made it better. And then that process has continued all the way to our iPhones or our Samsungs or our smartphones in general, we could say. Why is reverse engineering used? There's basically four reasons: documentation, discovery, investigation, and product improvement. So let's talk about those four. First one is documentation. Sometimes a product has been around for so long that there's no existing documentation. So what a company wants to do is they'll have to tear it apart and reverse engineer their own machine or their own invention so that they can get documentation on it, whether it's IPTs or IDWs, something that verifies how it's made. Interoperability. I'm not exactly sure that we're going to go into that a whole lot. Maintenance. Sometimes they'll reverse engineer and see can they make it better so that it's easier to maintenance. Another reason it's used, this is another reason, this is the second reason that we're going into it, is discovery. Alright, the Human Genome Project, alright, they're reverse engineering humans as they start to learn about humans. They're reverse engineering our brains. They start to dissect our brains. All right, they do this for academic research and learning and curiosity. All right, that's the main reason we use reverse engineering for discovery. Is we're curious. All right, you guys used to get, a lot of you kids in here, when you got Christmas toys, by the end of the day you'd have it torn apart. You got something that ran on batteries. By the end of the day it wouldn't work anymore because you tore it apart. You wanted to know why or how it worked. Still talking about that discovery, academic research, learning, curiosity, military or commercial intelligence. Over here was the B-29 bomber. All right, over here we have the RQ-170. These right here have been, the RQ-170 is for the most part a reverse engineer of the B-29. Investigation. This is our third step now. Investigation, analysis and testing, document patent infringement, forensics, design failure. With this now, with investigation, again, they're going to be doing a lot of analysis and testing of a part. What can they do with it? Documentation, patent infringement, forensics, design failure. When does it fall apart? What can they do to make it better? But they're investigating. They're going to be doing a lot of testing during investigation. The fourth one is they want to improve or redesign a product. All right. Increase efficiency. Can they make it run on less energy? Improve reliability. Can they make it better so that maybe when you drop it in water, it still works? I mean, how many cell phones have people gone through in the last 10 years because they dropped it in water? And putting it in a bag of rice doesn't always work. Improve manufacturing techniques. Can they make it so that it's easier to make? Eliminate failure mode. Can they make it so that it doesn't ever fail? Reduce the costs. That's a great reason to engineer. If you can put less money into it, that increases your property margins. Increase the ease of use. A lot of you guys are always having to do updates. Why? Because a lot of times it's making your computer easier to use. It's making it faster. Reduce negative environmental impacts. Reverse engineer it. See, can we use less poisonous materials in here? Reverse engineer it to use recycled parts. Is there a way to do this now where we use recycled parts instead of parts that are non-recyclable? And those reasons can go on and on and on. Some different tools that are used to reverse engineer. We use micrometers, use calipers, optical probe. We won't really be using any optical probe or medical imaging device or interactive visualization. None of that we'll be using, but those are all things that are used in the real world when it comes to reverse engineering. Well, hey, that's a short session of notes for you guys. Hope you guys learned something from that. I'll catch you on the flip side.